Hi, I want to talk about a class of musical instruments based on the idea of an open-closed organ pipe. Now, similar to an open-open organ pipe, an open-closed organ pipe has a set spectrum of resonances that are called harmonics. However, the big difference is open-open organ pipes have all possible harmonics. Open-closed pipes only have certain harmonics available to them, and it's based on how the resonance comes about. If you have an open end of a pipe, you have to be at a displacement antinode. The gas has to be able to move its maximum amount. If you're at a closed end of a pipe, you're at a displacement node. Gas can't magically tunnel through walls. So we would need to figure out a wavelength such that we would go from a node to an antinode inside the space of the pipe. So what we could do is we could start at the node, go up to the first antinode by the time we reach the length of the pipe, and that means that the length of the pipe would represent 1/4 of the wavelength of the sound. And it would be like 3/4 of the wavelength were outside the pipe. Now the next case where we could go is, again, we start at that node, go to an antinode, back to a node, up to another antinode. That gives us 3/4 of the wave inside the pipe, and another 1/4 of the wave would be outside. The next case we get node, antinode, node, antinode, node, antinode. We would have 5/4 of a wave inside that pipe. So the pattern that emerges is the wavelengths are equal to 4 times the length of the pipe divided by m, where m is an odd integer rather than any positive integer that we can come up with. So our frequencies we'd find similarly to how we have frequencies for an open-open pipe. They'd be the speed of sound divided by the wavelengths that are allowed. So our frequencies here would be that odd integer m times the speed of sound divided by 4 times the length of the pipe. And we still have harmonics. We would still consider that to be our harmonic number. 1 would be our fundamental frequency, so our harmonics would be the harmonic number times the fundamental frequency, but we only have odd harmonics available for the case of having an open-closed pipe. Thanks for watching.